So, hi, I'm Mark Steve Samson. I'm a senior data engineer at Thinking Machines. So you can view this slide or this deck from my website as well. And you can email me for like corrections or violent reactions with this address. So what does SVG stand for? So it's Scalable Vector Graphics. Okay, thank you. So how scalable is SVG? It's quite scalable actually. This is not true though. It's not to infinity because you'd blow your mind if that's the case. It depends on your hardware or actually the renderer that does the rendering of your SVG, which in most cases would be your browser. How does it scale to such extent? Well, using maths. Pero it's not really that difficult. It's more of geometry. So here's an example of a raster image and a vector. From where you're looking at, you don't see you won't see much difference. But if I zoom in, you will see how blurry the raster image is, and how the SVG is still crisp. But why? That's because raster images are stored in like a grid of pixels. In the simplest form of it, like for example, bitmaps. Bitmaps is basically a map of bits. The bits correspond to the color. So for example, if this image is like around 300 by 300, you would have 300 by 300 bits of white or not white, or in this case transparent. While vectors stores the image information as geometry. So for example, these lines would be represented as path elements. So that in turn makes SVGs quite smaller than their raster counterparts. But this depends on which cases you use it. For example, you really can't use SVGs or vectors in general for images like photographs, which contain a lot of color information. Raster images would work better since they have specific compression algorithms available, like for example JPEG or PNGs. But for the use case we'll be going through, SVGs would be better off. So another another way SVGs get smaller sizes is because of gzip. So since you're writing, since SVGs are written in plain text, they get a lot of compression from gzip. So how does SVG look like? So it looks like this. So it's XML based, so very similar to how HTML looks like, since they are both markup languages. And because of that, SVGs are highly compatible with JavaScript and CSS. So that means you can style with CSS, you can make it responsive, animatable, interactive, and much more. Can I use it now? According to Can I Use, it's very much supported in the majority of the browsers. So how do you write SVGs? You can handwrite SVG. We have vector design softwares available like Illustrator, Inkscape, and Sketch. They all export to SVGs. In fact, most of the vector editing softwares would be able to export to SVG. Or you can also use code. For example, there's D3, 2JS, etc. So they have nicer APIs that will allow you to create SVGs that won't make your brain explode. So how do you use SVGs? There are 3 ways. So the first is with image tags. So you just treat them as normal images. Nothing fancy about that. You can also use them as background images. And finally, you can inline them. So since SVG pretty much looks like or is compatible with HTML, you can just put it inside your HTML. One bonus to this is, like I mentioned previously, is the ability to be styled with CSS. So notice I added a class red here. So if we define that CSS, so let's go back. So here we have two elements, the circle and the path. So since I said I defined in the CSS that the stroke of the circle would be red and the fill of the path would be red, it turned red. Yay. This works with inline SVGs. These two examples, the two previous examples, won't actually work. How do you style with external SVGs? You can use use. So there's a use tag where you can specify the href attribute for an external SVG. And this would make your SVG stylable with CSS. So here's an example of, or here's what's inside external SVG. So it's kind of the same with the normal SVGs, but here we define our actual image information as a symbol and assign an ID logo. So as you see, we use it like this. So we use this. This is called the Fragment Identifier. So since we defined it as logo, the ID as logo, we can use it as like this. So now we can style it with CSS. But what happened here? It didn't really work. Let me show you why. So if we inspect, I'll make this bigger. You'll notice that it's not really inline. Like the use has this shadow root thing. This is in fact this is actually a shadow DOM. So use is a shadow host. You can interpret it as like an alternate dimension. So it's self-contained, like the scope, the styles and everything inside the use would not be affected by your parent document. So, but I said that you can use use to style SVGs, right? There's a solution, which is inheritance. Albeit it's kind of ugly. See, we can define, we can add another a custom CSS in our elements to inherit whichever property we want to change. So for example, here the circle, we want to change the stroke so that it inherits from the parent, and the path should inherit its fill from the parent. The parent in this case would be use. So if we define stroke as red and fill as red in the use, it would translate this to like applying the styles. But what if we want to, for example, the circle, we want to fill it with a different color, but fill has already been used here. There's yet another hacky way to solve that using current color. So if you're not familiar with current color is basically the current color of of that scope. Or this is defined using color. So this is basically the text color. So for example, here in circle, we just set the fill to the current color. So now we can define color as white, and that would make the fill white here. So that just adds one color. What if we want to add multiple colors, etc., etc.? Well, there's the future. In the future, when CSS vars are finally generally available, we would be able to use this. So instead of setting it as setting the value as inherit, we can define a CSS var, or put the placeholder for the CSS var here and define it in the parent element that we'll be using. So for example, here we have Raspberry Rapture, Butter Pecan. These are FIC ice creams, if you're not familiar. Really good. Here. So this works. But not in all browsers. Only the browsers that support CSS bars for now. Now for how about being responsive? So for example, here we have a normal SVG, and we define the breakpoint at 320 pixels that the circle would display none at that breakpoint. So if we resize, it vanishes. From the examples I've shown you, you would notice that the SVGs would scale automatically. That's not actually automatic. You need to learn the concept of viewport and the viewbox. So viewport is basically the size of the SVG. For example, your browser has a viewport, which is the window size. It's the same with SVGs. So if you define either through the attribute or the CS or your style sheets, the size, that's your viewport. Then there's also the concept of viewboxes. The viewbox defines the coordinate system that your SVG will be using. So for example, here with the viewbox, it would scale properly. But if I don't define it, it would just use the default values and be small like this. There are other properties that help out with preserving aspect ratio or anchoring your SVGs to the viewport. Look them up later, specifically the preserve aspect ratio property. Now, that was like a makeshift animation using the viewbox. So I just basically modify the attribute, the viewbox attribute. But if you want to do proper animation with SVGs, you can use SMIL. Actually, don't use SMIL because I'm not even sure if you can say SMIL or SMIL. It's an ancient specification in SVG. It's being deprecated in favor of CSS animation. So it still works. It still works, it still works for now, but eventually it would stop working. So just go for either JavaScript. So this is my favorite. This is technically not an SVG animation framework per se, but it's more of a, to call this, a two-dimensional drawing API geared for modern web browsers. But it has a renderer that can render with SVG. So this is my go-to if I need to do vector animations. But you can just use good old CSS animation. So I defined two keyframes here, the rotate and scale. You can use them using the animation property, setting the transformation at the transform origin. That would give us this. So quick animation using CSS and SVG. You can also so this is not a 3D this is actually not a 3D canvas. It's SVGs being projected as you move your cursor. So if you see here, there's not a mention of 3JS or whatever here, or CSS 3D properties. It's just this magical function that shape shifts the map the SVG so that it looks like a globe. Since SVG works pretty much like HTML, like you would be able to do most of the interactive stuff with SVGs. For example, you can use CSS to add hover effects. You can use JavaScript to handle events. You can also use SVGs for masks. So this is something we did before in ProdCloud. So here's a small SVG file or path that I use as a mask. So thing here is a white div, but since I'll show the CSS. So since it uses the clip path, which is defined here, it gets cut off like that. So with just decreasing opacity, we created this effect. Finally, a quick note on optimizing SVG. So there are a few ways on how you can optimize SVGs, like the transport of SVGs. You can gzip it. You can compress it using this tool. So SVG OMG is a GUI for SVG-O, which optimizes SVGs. So this tries to optimize by recreating your paths in like a more optimized way. For example, this logo, the TM logo. Initially, when I created it, it was like 36 lines of varying width and rotation. But if you look at this definition, it's just 15 paths. So how did that happen? SVG-O optimized it by making this intersecting lines together, like it merged it together to make it more optimized. So if you want to learn more, this deck is available in the URL I posted earlier. So if you are interested in learning SVG more, it's good to look up these resources, especially this one. This presentation, it's like 100 slides of cool SVGs, cooler than what I've shown you. So that's it. Thank you.